We're in the process of creating schedules. So I have a certain number of jobs that are coming through a job shop. This is identified in this matrix where I have these three jobs, A, B, and C, and then three workers that I have to assign to these three jobs. Now, these numbers, we don't really have an idea yet what those mean, but they are opportunity costs or the costs of assigning each person to each job. And what we'd like to do is we would like to find a way to um, assign each job to the worker that's going to in some way minimize costs. It's not as obvious as it seems at first. I mean, I can't just look at this matrix and say, oh, it looks like person three should have job B and job A for person three, uh, job one for person B, and then just whatever's left over for person C. I mean, that almost hits it, but not quite. And certainly in a more complex system, I don't think we can eyeball it like that. So what I want to do is I want to work through this process that your author goes through in his example 19.1. And I want to teach you, I mean, your author is trying to teach you as well, some basic matrix operations. Now, I hesitate to say that because some people believe they're mathematically challenged. I obviously don't believe that. I think it's just people are too lazy to learn math, but that's neither here nor there. Uh, what I want to do is, these operations are pretty simple. And so let's follow through in the steps that your author has outlined. This step is called a row reduction. And what I'm going to do is I'm going to go row by row, one at a time. And I'm going to take the number 13, for example, and I'm going to subtract from it the minimum number in this first row. Well, the minimum number is going to be 8, but I've set it up so Excel can do that classification. And then I do the same thing to the next number. I subtract from 16 the minimum in that first row, and then I subtract from 8 the minimum in that first row. Now, I did step 1 in 2 steps, but it could have been done in 1. I just wanted to show it right first. Then I have to repeat what I did for row 1 for rows B and C. So again, I work my way across row 2. I take the number 10 and I subtract from it the smallest number in that column, which is 10. So I should get a 0 there. Then I subtract from 12 the smallest number in the second row, which is going to be 12 minus 10. Then I repeat the process for the number 13, subtracting the minimum number from the second row, which is 10, so I'm going to end up with a 3. And then I did combine steps. This time I repeat for the last row, so I've got 11 minus 9, 14 minus 9, and 9 minus 9. Okay? So step 1 says I have to do this operation for every single row, and that's true. I can't just do it for one row or another row. I have to do it for everything. Now, step 2 kind of reverses things, which is why I show it going down a column. And I did step 2 in just one step from this matrix to this matrix. Okay? And what step 2 says is, well, let's go through and let's subtract from the columns, so column 1, the minimum number in that column. Well, 0 is the minimum number, so 5 minus 0, well, that's just going to be 5. And let's do this again here. Whoops, a little fast. 0 minus 0, that's still 0. And 2 minus 0, which is also remaining 2. Okay. Move to the second column. In the second column, I take the smallest number in the second column, which is 2, and I subtract from it, then from 8 I subtract that minimum number, which is going to leave me with 6. And then I'm going to take the minimum number in the second column, which is again 2, subtract it from 2, which is going to leave me with a 0. And then from 5, I'm going to subtract the minimum number in the second column, which is 2, and I'm going to get a 3. Okay? Now the minimum number in the third column, like the first column, is going to be 0. So I went through the operation, but it's not going to change anything because, well, you know, subtracting 0 from numbers doesn't change anything. So step 1 is for each column, find the minimum number in that column and subtract it from each element in that column. And I've got to do that for every row. Boy, I think I just said that wrong. Let me try it again. Step 1, for each row, I find the minimum number within a row and I subtract it from all the elements in that row. Okay? And I do that for every row. Step 2, I repeat step 1 in a way, except this time I'm doing it for columns. In step 2, I find the minimum number in a column, and I subtract it from all of the other numbers within that column. Alright, step 3 says to cross out the zeros in the table by using the minimum number of horizontal and vertical lines. So I do that. I think, okay, well, I could cross out this way, and this way, but that's not the minimum, right? 3 of them. Now I can cross them all out with 2 of them. One going across row B, one going down column C, and I have all of my zeros covered. Okay. Then I need to check and say, okay, in step 4, if the lines from step 3, 2 in our case, we have two lines, equals the number of rows or columns. They don't. We have 3 rows and 3 columns and only 2 lines. So I don't get to stop like I would had there been 3 lines. Alright, so I move on to the next statement. If the lines from step 3 do not equal the number of rows or columns, if the lines from step 3 do not equal the number of rows or columns, then here's what I've got to do. Subtract this is different. This is not repeating steps 1 and 2. I'm going to subtract the minimum across all values in the table from all other uncrossed values in that table. So here's what that means. Okay, from the number 5, I'm going to subtract the minimum of the numbers that don't have a cross going through them, or excuse me, a line going through them. So let's see, 5 minus, well, the minimum of these numbers is 2. That's going to leave me with a 3. 6 minus the minimum of all the uncrossed through numbers, so that's going to be 6 minus 2, which is 4. 2 minus 2, and 3 minus 2. And then I go back to step 3 and I cross out all zeros in the table by using the minimum number of horizontal and vertical lines. So I have another 0 that was created. I am going to draw a line this way horizontally. By the way, I could have done that vertically, although, yeah, I could have done that vertically. Oh, wait a minute, I forgot this 5 right here. After I've done my subtraction that we just went through for each of these values, I have to do an addition. So add the same value. So my number 2 that I was subtracting from 5, 6, 2, and 3, I'm going to add to the number that's at the intersection of my lines. So the intersection of my lines is the number 3. I add 2 to get the number 5. So if I go down to this 5, I'm going to take 3, or 17, and I'm going to add the minimum of the uncrossed out numbers. Not really relevant right now, but that is a step that needs to happen. Now I go to crossing out. I could have crossed out this first column rather than the first row. Not going to change the outcomes any. And then I count the number of lines, 1, 2, 3 lines. I'm here in step 4. The lines from step 3 now will be 3 equals the number of rows or columns, which is 3. We're done. We stop. And now we just got to figure out the optimal solution. Okay. Well, the optimal solution is to go into each row and find which person is associated with the 0. Oh, okay. For job A, across this row, only person 3 has a 0. Going to give them that job. It would be easiest if we now skip down to job C. Okay, I'm not giving it to person 3 because they're already doing something. But person C should then get job C should then go to person 1. So job C, person 1. Now let's go back and B gets what's left over. Person B gets the job that's left over, which is B. Okay. So why not some other configuration? Well, this other configuration, A is correctly assigned, and actually B is assigned in a good way. Right? Job B could be done by person 1. But then that leaves job C to person 2, which is not optimal. Okay? So, we got to play around a little bit. We want to make sure that we can fit or come as close as possible to fitting each job with one of these zeros. Okay? All right. Hopefully that helps. Good luck with this. Thanks.